Hey folks, welcome back for another episode of Code Club. Glad you could join me today for this live stream here on YouTube. If you are new to the channel, know that I love to recreate and refactor data visualizations. And so an example of what we will be working on today, if I can get my keyboard right, is this panel D from Figure 2 of a paper published in the journal Nature Microbiology. The title is Targeted Innate Immune Inhibition Therapy Compared with Antibiotics for Recurrent Acute Cystitis, a randomized open-label phase 2 trial. This was published not last month, 2 weeks ago, February 12th of 2026. This is late-breaking data visualization, critique, and refactoring. Nature Microbiology, if you're unfamiliar with it, is a pretty highly regarded journal. For what it's worth, I don't know that it's much. The impact factor is over 20 or about 20, which is far higher than the journals I typically care to publish in. And that, I think, if anything, just goes to show that people think a lot of this journal. And so the overall story isn't really important for what we're doing today, but just to give you some background so you know where we're coming from, that we are... half of women over the course of their life, so half of women, that means a quarter of all humanity, will experience bacterial infection of the bladder. And that's called cystitis. And so the typical treatment for cystitis is antibiotics. And so a couple problems with that. So first is that they tend to have recurrent infections. So women that get cystitis tend to get cystitis again. There's also a concern of antibiotic resistance. And so in this study, they were taking two drugs, both of which, as I understand it, or at least in the US, approved for clinical usage. The first is nitrofurantoin, the antibiotic, nitrofurantoin. I can't say it. And then the other is an IL-1 receptor antagonist, anakinra. And so this is an immunologic. So I'll probably go back and forth between referring to the nitrofurantoin as the antibiotic and the anakinra as the immunologic. And so the benefit of the immunologic would be that we don't have to worry about antibiotic resistance, right? And so perhaps also then that might reduce the likelihood of recurrence of infection. So in this study, as they say here in the abstract, they had a total of 30 adult female patients with a history of recurrent cystitis, and they put 20 of the women into the anakinra, the immunologic arm of the study, and 10 into the nitrofurantoin, okay? And so again, the figure that I'm interested in is figure 2, in particular panel D. I am a sucker for pie charts. I generally don't like pie charts, and I'm always trying to look at a better way to represent data than in a pie chart. And so that is the task today. So if this is all news to you and you haven't seen this on YouTube or coming from me, well, that probably means that you're not subscribed to a couple things. So first of all, if you go to rifamonas.org, I'll go ahead and copy and see if I can... I don't seem to be able... Let's see. If I make this... For some reason, I don't have access to the chat, which is... Okay, there we go. And so that is the link to this page that I'm showing here. And if you just scroll down gently, you'll get added to my mailing list. And so typically what I do on Fridays is send out a newsletter where I present a data visual, and then I present at like a 30,000 foot view how I would go about recreating that visual in R, okay? The other thing that I do then is typically on Monday, and so that's this newsletter, as you can see here. So I will go ahead and paste that into the chat. All right. And then on Mondays, I put out a critique video where I go through a visual and I then critique it, right? And I do what I consider a constructive critique, where I try to give the context, I try to give information about kind of the structure of the plot, I try to interpret the plot, and then I render my judgment or my assessment of what would make the visual easier for an audience member or for an individual to understand, okay? And so what I'm going to do in this live stream is take some of those ideas that were in the newsletter as well as in the Monday video and then try to implement them. If you haven't, consumed any of that other content, don't worry, stick around. I think you'll still get tons out of this visual. I think they are fairly independent of each other, and you shouldn't have to worry so much about having missed that other content, okay? All right. And so as you log in, please let me know who you are and where you're coming from. I see already we have Hassan from West Virginia. We have John in Barrington, Illinois, and Jamal from Connecticut. So I think I made a comment last time about where are the people from the US? And of course, these people gently reminded me that they are very much in the US. So as you come in from all points around the world, please feel free to say hi and tell me who you are and where you're coming from. All right. And so this, again, is the pie chart that we are going to be working in. And I'm having a little bit of problems with my controls here. That's okay. All right, good. Okay. Just get some things situated and we should be in good shape. All right. So, cool. So one of the things that I try to do in picking the figures that I present here on the channel is I try to pick figures that are in articles that are open access. I also try to pick articles from journals that have these very high impact factors so that there's no debate about kind of the quality of the science. I mean, there is still debate about the quality of the science, but whatever, right? It's in a prestigious journal. It's not like I'm picking some, predatory article from predatory journal, right? So picking something that people hold in high regard. And so this open access, and then the other thing that I try to do is pick figures where the data has been made accessible. And so we can see that there's this link here for source data figures 2 to 4, extended data figure 1. And if I hover over that, then at the bottom, I know it's probably small where you're at if you put your face right up to the screen, perhaps you can see that that is a link to a Microsoft Excel workbook. So I'm going to go ahead and copy that link address. And then let's head over to our studio and we will get going. And so I have a script called cystisplots.r that all the code that I will be generating today, I will be posting to a blog post. So if you go down below in the description for today's video, you can get that link. I am going to try to do a couple things today, okay? And so this might be overly ambitious, but I am going to start by, where'd you go? Start by actually trying to recreate panel D. Now, I do not encourage the use of pie charts, but there is something that stood out to me about this that I was thinking, well, I'm not going to do pie charts because I can't do that in R. And so there's this adage that whenever I make these videos, it sits in the back of my head. And that adage is that a poor craftsman blames their tools, okay? And so I have yet to get to a point where I have said, oh, R doesn't let me do something. And so I'm not going to let today be that day, okay? So this set of pie charts is interesting to me because I have looked at a lot of plots. I've made a lot of plots in R and using facets. And so facets are a way that you can basically present figures in kind of a tabular form, right? So you can imagine that this is a figure that has 4 columns and 2 rows, right? So that's what I mean by tabular form. And so what's interesting is that the spacing between the first and second columns is the same as between the third and fourth, but different than the spacing between the second and third columns. And so typically when we use something like facet wrap or facet grid, the spacing between all of the columns has to be the same. And so this was the challenge. The other thing that you might think of was like, well, within one facet, could you put 2 pie charts? And as far as I can tell, you cannot easily put 2 pie charts within the same facet, within the same panel, right? So you can imagine this being one panel, this being another panel, this being another, and this being another. Except that there's no clear way to put 2 pie charts within the same panel, okay? So I have, over my journeys of making figures for papers that I've published, come across a package called ggh4x. And so ggh4x, Don't exactly know what it stands for. Maybe if we Google it for X, it is, oh, it's hacks for ggplot2. And so I think the developers of this 2in brand, actually works on the ggplot2 team as well. And so this is, as the title suggests, an extension package that provides you hacks for working with the grammar of graphics. And so, as they say, things that don't entirely fit within the grammar of graphics concept. And so they can be a bit hacky. All right. And so we are going to be able to use nested facets from the ggh4x package. And so that's what I'm going to use to make these pie charts. And again, I'm not telling you to make pie charts by any means, but what I'm trying to do is introduce you to a new package, this ggh4x, and the ability to make nested, if you will, facets, because that does come up periodically as you're trying to make more complicated data visualizations. And so we'll do that. So that's where we're going to start today. And by the end of the episode, hopefully we will look at 2 alternatives to pie charts for representing that data. Okay, one is going to be a stacked bar plot, I know, and the other is going to be as a dot plot. And so we'll talk about the strengths and weaknesses of these 3 plots. But that's a lot to do, so let's go ahead and get going. Welcome, Rents from the Netherlands. Great to have you. So, like I said, this is my data URL. And let's go ahead and load all our stuff. I also have in here a ggsave statement to save out to a PNG at, I think, pretty close to the dimensions of that panel D as a separate file. All right, so we'll go ahead and do download file, and then I'll do data URL, and I will save this as cystitis data.xlsx. All right, and so if I look over in my Files tab, I now see I've got my cystitis data XLSX file. All right. So again, you could download this manually, put it in the directory. That's fine. I'm trying to make it a self-contained script so that you could get this script, run everything, and get what I get. Okay. All right. So now we have this cystitis data XLSX. Let's go ahead and do read Excel. And we'll plop that in. But of course, to use read Excel, we need to do library read Excel. And let's go ahead, and I thought I had my Finder window open, but maybe not. And let's go ahead and open that file so we can understand the structure of it. And I will go ahead and make it bigger. And so we're interested in figure 2, which is this first panel. And let me make that bigger. And so what we can see is that this is in a tidy framework. And the data that we want is in column E, which is the dynamics. And so again, coming back to this figure, we see there is a title here. It's kind of buried. Change in symptom relief dynamics relative to enrollment day 1. And so that's why on day 1, this visit here, we see that there's a blank cell. Okay, so we're going to want to read in tab fig 2. So that's the default that would get read in, right? So that's this table already. But I want to be explicit about what we're going to do. So we'll do sheet equals fig 2. Again, we get the same output here, right? And let's focus in on the data we want. And so I'm going to do a select. And at the same time, I'll go ahead and rename things. Or, you know what? Maybe I'll just rename everything. So we'll do rename all, and I'll do to lower, and that will get everything to be lowercase. And then we'll go ahead and do a select. I'll get patient, treatment, visit, and then dynamics. Okay, and so this then allows us to focus on the data that's in that panel D. All right. So again, feel free to leave any comments or suggestions or thoughts along the way, and certainly please say hi if you're joining us as well. It looks like there's about 18 people watching, so not all 18 of you have said hi. So anyway, let's now think about our dynamics. And I want to do a count on dynamics. And we see that there are, well, there's NAs, right? So that's the day 1. That was that blank cell. And then we have values of 0, 1, 2, 3, and 4. And if we come back and we look at this panel, we see that the green are for values 0 and 1. Some symptoms are gone is this yellowish, orangish. And then the same symptoms are worse is 3 and 4. And so I want to bin together these values of dynamics. So maybe what I'll start by doing is drop an A on dynamics. And of course, if we pipe that to count, we then get rid of the NA value. And then let's do a mutate to create a response column. Okay. And so let's do case when, and I'll do dynamics less than or equal to 1. And that they call all or most. So I'm going to call that, I could call it like the whole thing, but I'm going to wait on that. So let's do all, I guess I need tilde, all dynamics equals 2. We'll say sum dynamics greater than or equal to 3. And that then will say worse. Maybe I'll do better, some, worse. All right, we're going to change those labels eventually to match what they had in the original panel. And so then we can pipe this to count. And here then let's do response instead of dynamics. And so now we see that we've got 91 better, 18 some, some of the symptoms are better, and then worse is 10. Okay, cool. So that is that data. Now, let me go ahead and remove this count because I think there's some other things that we're going to want to mess with. And so the other thing I want to mess with is this visit, where we have day 5, day 15, day 30, 6 months, right? And so I would prefer to have it be like 5 days, 15 days, 30 days, 6 months, right? And also to put a space between the number and the day. So I'm going to go ahead and modify that as well. And so we'll do visit equals, and let's do what? Let's do another case when. We got case when on the brain. Case when visit equals 6 months. Then we want to change that to be 6 space months. And I need that H, all right? And then otherwise, I'll do, well, let's do str detect. So we're going to detect in the visit column if it starts with day. Okay, so if it starts with day, so again, with the case when statement, we're using a logical question. And if this logic is true, then we're going to get what's on the right side of the tilde, right? So back up here, if the dynamics was less than or equal to 1, it's going to return better. If it's 2, we're going to get some. If it's 3 or greater, we're going to get worse, right? So in the same case, if the visit is 6 months, then we're going to get 6 space months. And if we detect the word at the beginning of the string as day, then we are going to do something else. So we'll do str replace, and we'll do visit. And so then we need to give it a pattern. And so I'll do day, and then in parentheses, I'm going to do back d star parenthesis, right? And so that parenthesis is telling str replace to save what's in this parenthesis, because we're going to use that in the substitution, right? Or in the replacement value here. And so here then what we'll do is back, you need to do it in quotes, back 1 days, okay? So we run that, and now we see that we've got 5 days, 15 days, 30 days, right? So that's a pretty handy little tool. And, you know, we could have done this as an if-else. Maybe I'll do that real quick. So if we do if-else, visit equals 6 months, then to the left of that, we're going to put what's true. Otherwise, I'm going to put this other string replacement. I guess if else works well when you've got like a yes or no, right? So if I had something other than 6 months and day, then case one would probably have been preferred. But I guess the risk with an if else is you've got to make sure that you only have those 2 categories, right? So again, this works. And just to test, let's go ahead and pipe this to account on visit. And then we see we've got 15 days, 30 days, 5 days, and 6 months. One thing to note is that at 30 days, we have one one observation missing, right? There are 30 subjects, and so we only have 29 for one, and that is probably because, why would that be? I think because we are missing somebody that had that observation, right? Like that somebody didn't have, they're either better or worse. There was no sum. And actually, if we come back and we look at that's day 15, that's actually at day 30, which is interesting. And maybe that's why we get these weird percentages, right? Like 79% and 16%. Okay, so that explains that, right? Whereas everything else we have 10 or 80. That person must not have shown up for their appointment or something, right? All right, so cool. That's good to know. And let's again look at our data. And cool. And so then we've got all this. Let's go ahead and call this D for data. And now we're going to go ahead and try to make this into a pie chart. So we'll take D and we'll pipe it to ggplot, AES. And I'm going to show you something about pie charts. So pie charts are stacked bar plots in radial or polar coordinates. Okay. And so let's see. So if we do x equals, let's filter. Okay. So I'm going to filter onto like one case to show you this, right? So I'm going to take this anakinra and 5 days. So we'll do filter treatment equals anakinra and visit equals 5 days. All right, and I see that Rents is a little bit ahead of us, so sit tight, we will get there. So on X, I'm going to put 1, and on Y, I'm then going to put response, and then we can do like geom bar, and it's upset with me because, why are you upset with me? Oh, because I added after a filter, so that should be a pipe. All right, now it's upset. Stat count must only have an X or Y aesthetic, and let's see, if I do that, does that work for a bar plot? And let me hide my face. So here you can see we've got this bar. It's not exactly what I want. If I do like X, I get those. So those aren't being dodged. If I want these to add up to like 100%, I'm gonna have to come back up to my D. So what I'd like to do is to plot, well, let me show you. If I did like geom, oh, I see what I did. So if we do X equals 1 and fill equals response, right? And so now we get a stacked bar, and that adds up to 20. And if I then do chord radial, and then I do theta equals Y in quotes, that is going to set the Y position related to the angle in the pie chart, right? And so there we go, we get that angle. And what you'll notice is that there's a gap here. And so that gap is because of the expansion factor, right? So if I come in here and then do expand equals false, I get my filled in pie chart, right? Okay, so I think I was starting to say, well, I was starting to say like let's turn this into fractions, but maybe what we'll do instead is to make this into a facet. Okay, so I'm gonna remove this filter statement, and then I'll do facet grid, and in my rows, it's a little bit different than what I normally do. I'll do vars equals, and so in the rows we're gonna want visit, and then calls, we're going to want treatment, I think. Oh, I guess that needs to be vars as well. And so here we go. We now have our two drugs in the columns. And then we have our rows are the visits. And again, a couple things you will probably notice is, again, as we saw for anakinra at 30 days, they were missing one subject, and that those had 20 subjects, whereas the nitrofurantoin had 10 subjects. And so we're only getting half of a pie chart, right? Because it's dealing in the actual counts. So let's go ahead and, as I was starting to say, let's turn this D then into displaying the fraction, okay? So again, this is what we have. And what I'd like to do then is to, let's do a mutate. Well, I guess that is a mutate that I was just in, right? Well, yeah, that'll work. So we'll do fraction equals, and let's see. Well, let's do count. All right, so I'm going to pull back. So we need 2 bits of information, right? We need the frequency of each response for each visit and treatment. And then we need to divide that by the total number of individuals where we had a treatment and a response. So let's go ahead and do a count on treatment, visit, response. And so now what we see is that we get 23 rows where we've got our treatment, our visit, our response, and the n. And so now we can turn that into a fraction by doing mutate fraction equals n divided by n parentheses. And n parentheses tells us the total number of observations within a group. And so then I can do dot by equals, and we're going to do it by treatment and visit. And so now what we see is something kind of weird. So n divided by n. Oh, I don't want n. I want sum. All right. Because n is the number of classes, right? So that would be like there's 3. But what I want is the sum, right? So like I'm getting 17 divided by 3, which is 5.67, which isn't what I want. I want the sum of the n column. All right. And so now what we get is that 0.85. I'm going to leave this in fraction for now. Brian asks, could you also free the theta axis? That's a fascinating question. Let's try that. So we'll do scales equals free. Oh, so that should go in the facet, right? We'll do scales equals free, and I'm going to turn off that expand. So that doesn't, I would have expected that to work, because with the free, that should make the theta, so that'd be like free y. Yeah, free x maybe. I don't think that's going to work. Yeah, so that doesn't seem to be working. Like normally when we're using like Cartesian coordinates, and we want like a different range on the, like let's say the y-axis, you can do scales equals free y, and then each panel will have its own y-axis. But that doesn't seem to be working here. So let's. That's a good thought. Very interesting idea. I hadn't thought about that, but that's cool. All right. So now we have our fractions, our proportions, and let's go ahead and reload D. And so now when we run this, we got something weird. Oh, and that's because I'm using geom_bar. And so geom_bar does a statistic, basically a count, before showing the data. So it's counting that there's 2 or 3 different categories. So I want here instead would be geom_call. And why are you upset? Oh, because I need to give y, right? So the y is then going to be fraction. And there we go. We now have our pie charts. And yeah, all right. So Let me go ahead and save this to piecharts.png, and let's see what this is looking like. And so we're gaining on it, trust me. So a couple of things stand out right off the bat is that we have, well, we've got 2 columns when we really want like 4 columns effectively. And our order is, it's alphabetical actually, or alphanumeric, right? It starts at 1, 3, 5, 6. So we want to reorder that. We also want to reorder our response. And because it's the opposite of the direction we want, right? So like this should be starting here at like 12 o'clock and going clockwise rather than effectively going counterclockwise. So we can change that back up here in D. And I think I'm going to do that back up here. And yeah, let's do response equals factor response. We'll do levels of better, some, worse, right? And so that will make it a facet. That doesn't change anything necessarily, which is fine. And then we'll also want to change the visit. And so we'll do factor, or sorry, visit equals factor, visit, levels equals, and then we'll do 5 days, 15 days, 30 days, and then 6 months. And maybe put this on a separate line so it doesn't wrap so far across the screen. All right, now when we try this, we now get 5, 15, 30, 6 months, okay? So this orientation of the wedges is a little troubling to me. So let's do chord radial. And so chord polar has been replaced in terms of, instead to use chord radial. And so let's see, there's, well, that's, let's see, we want chord radial. All right, so theta is x, start 0, and that. We've got some limits in here. And let's see, there's a direction, but let's see what it says about direction. 1 clockwise, -1 anti-clockwise. And I thought there was something else here. Reverse. Let's try reverse. We'll say reverse equals theta. And so that then did flip the orientation of that wedge to be in the order we want, okay? So again, we would like to have, we want these to be wider, right? And so one idea might be to create dummy variables where we make like combinations of the antibiotic or the immunologic and the time. I'm gonna jump because I'm telling you that's not gonna work because ultimately we're gonna want this extra space in the middle of the 2 sets of columns. And so let's go ahead then and bring in library ggh4x. And so what we could do with ggh4x then is to, let's see, we can do facet. Let's try facet wrap. Let's just try facet wrap on its own and see what that gets us. Oh, it's upset. So, okay, so if we're gonna do facet wrap, let me step back. I'm gonna go ahead and replace these with like a dot tilde, and then let's do treatment plus visit. And so then that's getting us, it's wrapping all those comparisons, but in here I could also say like nrow equals 2. And so then that puts that over 2 rows. And what I'm seeing is that it's putting the immunologic at the top and the antibiotic on the bottom. And so what I could do is I can like change this order. So I could do like visit plus treatment. And then that's going to do a lot like what we want, right? So we've got 5 days, anakinra, nitrofurantoin, 15 days, bam, bam, 36, so forth, right? One subtle point that I'll point out is that here it goes 5, 5, so it goes down over 30, down to 6 months. And so we can get that same thing to happen if I come back up here and I switch the order. So if I put 30 days before 15 days, I now have 5, 15, 36, right? So again, this is what I was saying where we have even spacing between all 4 columns, but we want like this extra space here. And so what we'd like to do with this ggh4x is to treat like the 5 days as a level of facet that within that then is nested the drug, right? And so we'll basically we'll nest the drug within the time. And so it's really straightforward. Once you've got things set up like this, is you do facet wrap 2, okay? And didn't do it. Why didn't you do it? Okay, so we have to add some extra stuff, right? And so then what we'll add in here, let me go ahead, and because I don't use this a lot, let me look at the help. There's no there's no shame in looking at the help. And so we see a lot of the same arguments for facet wrap. There is, let's see, there's a special argument strip. And so vanilla is the default. And if I come down here to the bottom, we'll see that there is strip and then vanilla. It takes a strip function, right? Which doesn't tell us a whole lot. And so I believe there's a variety of these strip functions. So if I do like strip underscore, I then see nested, split, tag, themed, and vanilla. I'm going to use strip split. And again, let's maybe look at a couple of these. So if we do nested, so I'm going to go ahead and do strip equals strip nested. And that'll get us this, right? And so this is, again, what I'm talking about with the nesting, where we can see that we've got one strip going over both columns, right? For the 5, 15, 30, and 6 months, right? Cool. What strip split does is that will allow me to treat the top, the top layer of the hierarchy separate from the lower level of the hierarchy, okay? And so let's go ahead and try that again. And so now what we get is we get, we get, let's just take this in. Across the top, we get the time, and now on the sides, we get the drug. And I kind of want it the opposite way, right? Where I want the drug on the top and the time on the side, okay? So let's go again into strip split. And what it allows us to do is that there's text X, text Y, background X, background Y. And so the text X, text Y allows me to send a list, as we'll see down here, with element text elements, right? And then, so that will allow us to modify that. But there's also this position argument, right? And so it's a character vector where the strips of the faceting variables should be placed. Can be some of the following: top, bottom, left, or right. So the length of the position argument must match the length of the variables, okay? So let's start there. So within string split then, we'll do position, and that's gonna be a vector. And so the visit I want on the left, and the treatment I want on the top. And there you go. You can see that we're gaining on it, right? You can see now we have the time on the left and the drugs on the top, which is cool. But I don't want the drugs on the top for the second row, and I don't want those there, right? So again, we can give strip split text X arguments, right? Maybe actually what I want is text Y. And so I can give that a list. And let's see, well, no, that is the X, right? Because I'm looking at the drugs. So we're going to give it 4 element texts and then 4 element blanks. And what that'll do is that'll show the drugs across the top, but not in the middle. So we'll do element text, and I'll repeat this a few times. And now we'll do element blank, and repeat this a few times. And maybe I'll play around with my indenting here. All right. Let me get this cleaned up. All right. And so now what you see is that we no longer have the text in the middle. And again, that's because text X is removing the text there, right? We could also then do, I think I got the wrong place. Right, so after text X, we could do background X. And we do the same type of thing, but with, well, I'm gonna want all 4 of these to be element blank. So I don't actually need to give it list. I can say element blank, right? And let me make sure I've got the right parentheses. I'm missing one. And so now what you see is that we no longer have that background, right? And so we have those labels across the top. Cool. And so now what we could do is let's turn our attention to the Y. So then we're going to do text Y equals list. And again, the example we're using here are pie charts, but really what I'm trying to show you is how we can play around with these facets using this strip split function and the facet wrap 2 from ggh4x, right? And so let's now, like I said, let's turn our attention to those Y labels. And so again, I'm going to want, now here the question is, does it go row-wise or column-wise? I kind of feel like it goes row-wise. So I think we're going to get 5 and 30 and blank and blank. And so what I just did was I looked at my code and I made a prediction about what's going to happen. And I think that's a really valuable thing that we should be doing when we're coding, because I am often surprised by how wrong I am about these types of predictions. And when we make a prediction, we're basically saying, what's my mental model for how this works? And is it right? So let's give it a shot and see if I was right. And I was right. It does go row-wise, right? And so what I want to do then is put this element blank up here. And then we'll go element text, element blank, element text, element blank, right? And so we've got that. And I want this text, though, to be turned, I think 0 degrees. I always get confused on those y-axis labels. There's an angle argument, so it's either 90 or 0. And again, it's pretty easy to change if we're wrong, but we'll try that. And there we go. We now have 5 and 15 days. And actually, I'm going too fast because I'm not thinking. I do want those labels there, right? All right. So I'm sure somebody was yelling at me. And so again, because I'm going to use the same element text for everything, I don't need all this stuff, right? I don't need the list. All right. There we go. Cool. So hopefully you can see that this is coming along. And let's go ahead to the background of that strip. And it's going to be the same type of thing as we did on the X, except we want background Y. And I'm missing a comma here. And so that goes away. And again, hopefully you can see this is taking shape. So now what I want to do is start removing some of this extra text. So let's go ahead and remove, let's go ahead and well, let's move our legend to the bottom. And we can do that with the theme function. And we'll do legend.position equals bottom. And so that's going to put the legend at the bottom. And let's now go ahead and remove the labels on the axes and on the fill, right? And so we'll do labs, x equals null, y equals null, fill equals null. There's a couple different ways that you can remove that title on the legend. This is pretty straightforward, pretty easy. And so now we've gotten rid of those labels. Now let's go ahead and get rid of, it's again weird to think about, but the numbers around the outside, like this 0, 1, 0.75, 0.5, probably 0.25, that is the theta scale, or the y scale, and then this ledger over here is the radius scale. Okay. So let's go ahead then in here, and we'll do, well, we can do that in theme. We can remove that in theme, where we will do axis.text equals element blank. And by not giving x or y, it's going to remove all of the axis text. And so we see we get rid of that, but we still have those tick marks. So we'll also do axis.ticks equals element blank. Gets rid of those labels. Okay, cool. Now, in theirs, they've got their drugs capitalized. So I'm going to go ahead and capitalize mine as well. Again, it's a very subtle thing, but it's the little things, I think, that go a long way to making our visualizations look more professional. So in here, I'll do treatment equals, and there's an str2 title on treatment. And so what str2 title does is it'll take something like, if I do like x equals Pat Schloss, and then I do str2 title on x, I get the first letters capitalized, right? So it's an easy way to programmatically capitalize the first letter and lowercase everything else. So now when we do this, we should get those drug names to be capitalized. Sure enough, they are. Cool. And so hopefully, I should step back and say that the reason we went through this process with the ggh4x is that we could get a different gap between the drugs within a time point than between the two columns of points of data, right? So I guess the other thing to think about in terms of labeling things now is that fill color. And so we have better, some, worse. And we could relabel this in a couple different places. I'm going to do it within a scale fill manual. So we'll do scale fill manual. And we'll then do what? Values. And here we can give it a named vector, right? And so we've got better equals something, some equals something, and then worse equals something. And then we're also going to have labels equaling those things, right? And so let's get the original. And here we have, if we can do better equals all or some symptoms are gone. So that's 0 and 1. And then we have some is some symptoms are gone. So that's the 2. And then worse is same symptoms or worse. And that's 3 to 4. And we need to get those colors in there. And so I'm going to pull that up and grab my handy dandy digital color meter. I'm going to copy the hex code and plop that in here for better. And then for the sum, we have this yellow color. I like the color scheme that they used. I think that makes some sense, right? Like, at least in the West, we think of red as bad or danger, yellow as like caution, green as like prosperity, good to go. Again, in other cultures, I think you have different connotations for those colors. But up, and I think I have missing a parenthesis. All right. Nope, I put the plus sign in the wrong place. All right, that goes there. All right. There we go. And so now we have their colors, and we have the labels across the bottom. And yeah, all right. Cool. And so maybe what we could do is, to clean this up a bit, we could then do, well, I'm going to put this back up with my legend stuff. So we'll do legend.key.size, and that takes a unit because the squares are kind of big, right? And so we'll do like, I'll do 8 point. And so you can see that those got smaller. I don't know if you can tell, but there's a gray background around those. And I can get rid of those by doing like panel.background element rect. Oh, not rect, blank. All right, going too fast. And so now, I don't know if you can tell, but that's gone. And so let's make the font a little bit smaller in the legend. And so we can do legend.text. And we'll do element text. And then we'll do size equals 7. And so then that gets that to be quite a bit smaller, and it all fits onto the same page, right? Cool. All right. It'd be nice to have those circles be a bit bigger. And so let's go ahead and do that. And so the radial coordinates puts it onto a scale where the spacing of the x-axis is the same as the y-axis. So if you go over 1 unit on the x-axis, it's going to be the same as 1 unit on the y-axis, right? And so that's like a chord equal, if you're familiar with that. And so I'm kind of thinking about how I want to do that. And let's see. So maybe one thing we could start by doing would be like panel dot spacing dot x equals unit. And let's try like 0 pt. So if we remove the spacing between those panels on the x-axis, what do we get? So that brings those together. I don't know that made it taller. So maybe we could also do panel.spacing.y equals unit 0 pt. And so that did make them a little bit bigger. Part of the challenge here is I can't quite see the boundaries. And is there a panel margin? No. Let's think here. Well, just because there's a lot of spacing here where there isn't a lot of spacing there. And maybe what we could do, if I come back to the spacing, what if I do like -10? Sometimes when you do negative, it like overcompensates, and that's kind of a hack, but it is often effective. So that I can tell made them bigger. So let's go like -20. Yeah, so that's working, right? And let's do -25. Cool, good. All right, I'm liking that. All right, and then let's bring the legend up closer to everything else. And so with that, we can do legend box spacing. We'll do unit. Let's try 0 pt. I like these extreme values because it shows me it's working and gives me a place to kind of work from. And so, believe it or not, that didn't bring it all the way up, which is interesting. I think there's a margin on my legend. So if I do like legend dot margin, and I'll do element or margin If I don't give it any arguments, it's going to use 0 all the way around. You can see that's getting closer, right? So I think that's a pretty good spacing. Let's think about these titles. They're, the strip is kind of far. And if I come back and, let's see the strip, element background. Why don't I go ahead and for now, turn off that background. That'll give us those gray backgrounds. And so you can see there is a bit of a margin around my text because that strip is, well, it's taller, right, than the text. So if I come back up here and do element text and then do margin equals margin, let's see what that first one looks like. Well, I think it's going to treat them all the same. Let's see. Boom. All right, do all 4 of them. Maybe they all need to be the same. Yeah, so that tightened it up, you can see. And also what you'll notice is now we've removed all the space between our panels, between our plots, right? But what I want to do is pull this down, and I'm not totally sure what's controlling that, but I think what I'll do is on the top of the margin, or on the bottom rather, let's do b equals -5. And so you can see that anakinra now is brought down, but it's getting clipped, right? So within strip split, we can also do, I think I put it in the wrong place, clip equals off. And so now you can see anakinra is outside of the box, which is great. And maybe we'll repeat this b equals -5 all the way down. And so that looks good. Now what we can do is go ahead and get rid of that element rect by uncommenting this code. There we go. But of course, we don't want our pies to overlap. So let's come back up to panel spacing. Let's take that down to -15. And that gets that some pretty decent spacing. All right. Now I think our times are center justified, whereas these appear to be right justified, right? So again, we're going to come back up to that text y, where we do that angle 0, and we can do hjust equals 1 to make it right justified. And that brings that over. And I'd like for those to be perhaps a little bit closer to the pies, right? And so again, we can come back up here. I'll do margin equals margin. I'll do r equals 0 as a starting place. So that actually made everything bigger too, right? Which is cool. Again, the chord radial or the chord equal, I find that's just really weird things where you change one thing and it changes a lot of other things. So it's good to kind of move in small steps. And so that's good. Maybe we want a little bit of space on the left of that though. So let's go ahead and do L equals 15. And so that might be a little bit too far. Let's take that down to say 10. And I think that looks pretty good. All right. And so now the final thing I'll do, well, not quite the final thing, is to remove the margin. So I'll do panel or plot dot margin equals margin all the way around. And so that gets us a little bit of spacing. And we could shrink the height of the plot and it's not going to pull things in anymore. But there's two things that are missing from here. And so thing one is the p-values, right? And so if you look at the original, they have a p-value here. And thing number two is the value in the quadrants. And so I think I'm going to start with the value in the quadrants. They put the percentages in, and I think I would rather put in the numbers, okay? So let's go ahead and do that. Let's go ahead and add the numbers. And so let's come back up here, and we're going to put that on top of the geom call. We'll do geom text. And then for label, within the aesthetics, I'm going to do n. And there we go. We have those numbers that are inserted into, some weird place. It's probably not where we want them. I'm not exactly sure what it's doing. Oh, I know what it's doing. It's placing the label at the theta value rather than adding up the theta values, if that makes sense. And so we can come back up to geom text and then do position equals position stack. And then we can do, well, let's leave that for now. And so now what we've got are our values at kind of, you might think of like the left edge of the wedge. And so we can get it to be centered by coming back up here to position stack and then doing vjust equals 0.5. And so that then centers those numbers within their wedges. They're a bit big for my liking. So let's go ahead in here then, and I'll do size equals 7, size unit equals PT. And let's go ahead and put these on the next line. And so now we have those smaller numbers in there. And that is a way that we can indicate the n of the number of observations we have, okay? So I like that, I think, better than the percentage. Like the size of the wedge tells you the percentage. The number, I think, tells you a bit more about the n, okay? All right, so nobody's been asking questions, so hopefully you all are still watching and enjoying. If you have questions, by all means, along the way, feel free to holler. And we'll see how that goes. All right, so the next thing I want to add in here are those p-values, okay? And let's think about how to do that. So if we come back to the original text, they tell us that they used a two-sided Cochrane-Armitage test to compare the treatment groups as reported, right? And so basically this p-value, this 0.7, is looking at the trend, right? So going from green to yellow to red. Does this proportion and in this order match in anakinra what we have in the nitrofurantoin, okay? So let's come back up here. And if we take D, we get this. And our response is already in ordinal form, going from better, some, worse. I think if I do like poll D response, I now see the levels are better, some, worse, right? So that's ordinal. All right. So we can get the Cochrane-Armitage test by doing library DESC tools. So that's like descriptive statistic tools that you'll probably have to install both of these if you've never used them before. And so the test is going to be that Cochrane Armitage test, right? And so let's take D and let's simplify things. And let's do filter visit equals 5 days. All right. And so then this gives us our 6 conditions where we have better, some, worse, better, some, worse. But Cochrane Armitage test wants things as a matrix. So we'll go ahead and then pivot wider. And I'll do names from equals response, values from equals n. Okay. And so then that is going to turn that into this. But we probably want to get rid of the fraction. Okay. So if we come in here and we do select minus fraction, pipe that in, then we get like this. And we could also, in here, let's do a select minus visit, because that visit isn't providing any information. And so then we get this. And now from here, we can do column to row names on treatment. And so what that's going to do is it's going to take what I currently have as a tibble and turn it into a data frame where the values in the treatment column become the row names, right? And so now we have this. And so now we can pipe this to Cochrane Armitage test And we see that we get the p-value of 0.7, which is exactly what they had here, right? And if I did like day 15, I get an NA. Why do I get an NA? Let's see. Oh, let's see. So that's 15 days. And I think I'm getting an NA here because I only have 2 observations, or because I have an NA value, right, in here, right? I've got that NA value. And so I think what I'd like to do is to fill that. And so one thing that we could do would be, again, if we take D and let's see, I want to pivot it wider and turn those NAs to zeros and then pivot it back longer. And so we have this here, but maybe it's here we want to do it, right? And so this is D. Yeah, so if we, let's see, let's pivot wider, names from equals response, values from equals n, then that's going to make it wide, but of course we have that NA value. And we can then do values fill equals 0. And again, now we have that 0 value. And now we can do pivot longer, and we'll do calls equals, and then we'll do better, some worse, and we'll do names 2 equals response, values 2 equals n. That needs to be in quotes. And there we go. But my response is a character rather than a factor. So maybe what we want to do is where I set the response to be a factor up here, I'm going to grab that and I'm going to paste that down here to be within this last mutate statement. Oh, and it's unhappy with me. Oh, because I forgot to add a pipe there. And so now what we get is that p-value of 0.569, which is exactly what they got, right? Okay, so now we have things set the way I think we want them, but we want to automate this over the 4 time points, okay? So this is where like our nest and our mapping and our unnesting will come in. So we'll take D, and again, we're going to modify slightly what we've done up here. I'm going to go ahead and include this select to remove the fraction because we don't need that for calculating the test. And then we'll do nest data equals minus visit. And so then this gets us 6 rows by 3 columns, which is way back up here. Oh, where were you? Way back up here. Oh, right about here, right? Or after that, right? Where we don't have the visit column, right? So we've got the treatment, the response, and the n. So we'll go ahead and pipe this then into mutate, and I'll say test, and then we'll do map, and then we'll do it on the data column. So we're going to take each row of the data column, which is basically each of these tibbles. What we'll do is I'm going to do a pivot wider, and we'll do names from equals, and we'll say response, values from equals n. All right, so I'm going to put these on separate lines. All right, so we're going to pivot wider, and we're going to do that actually on .x. Right? And we're going to pivot wider. So then we'll then do column to row names on treatment. Right? So you can kind of see what this looks like, right? Where we've got this test. And if I were to do like unnest on test, I could see that I basically have that data frame, right? Right. But I want to run the Cochrane. I want to run the Cochrane Armitage test as part of this pipeline, right? And so then we'll do Cochrane Armitage test on what's coming through the pipeline. And so this gets me a column called test with an htest object. And there's a great package called Broom that is installed with the tidyverse, and it allows us to easily format these types of htest objects, but it'll turn it into a data frame. Okay. Thank you for watching, Rents. Be sure to watch the rest of the broadcast later. And so let's see where we're. So in here, then we can pipe this to tidy. And so now what we see is that htest has become a list of tibbles, and then we can pipe this to unnest on the test, and bam, we get our statistic, our p-values, and so forth. I really only care about the p-values, so let's go ahead and do a select on visit and p-value. That gets us this table. And so what we'll do is we'll call this CA test, and then I want to add in more text. So we'll then do geom text data equals CA test. Yes. Then on the X, we're going to have to give this X and Y values. So the X is the what? The X is the theta? No, X is the radius. So let's start with like 1, and then the Y is the theta. And let's try like 0.4, see what that gets us. And then label will be p dot value. And pretty sure it's going to complain, but let's see what it says. Yep. So object response not found, and that's because CA test doesn't have a response column. I don't need a response. That's what we're using to set the fill color. So I'll do mutate response equals NA. So the other thing that we don't have is the other part of, I don't have the treatment, right? I've got the visit, but not the treatment. So let's go ahead and add a treatment. And I want this to be off the left side of the column. And so for that, I want it to be this Anna Kinra. And so we'll do Anna Kinra. And now let's see what it looks like. And boom, that's kind of ugly. So let's go ahead and modify that. We're going to need to make it pretty. So we'll come in here and I'll do I'll do pretty as I do. Pretty p equals round p dot value, and we'll do like digits equals 3. And I didn't want to do p value. I want to do pretty p. And so there we've got our p value, and it's on like the left side, and I think it's being center justified. So, but I also want to add something else, right? I want to add, I can get rid of this. I want to add like p equals. So let's come down here and we'll do paste 0 p equals that. And then so let's go ahead and load that. And then in my geom text here, I'm going to do hjust equals, let's try 0.5. And I'm going to say, I don't exactly know what the units are on Y. Let's try 0.8. So that moved it up. I think it's 0 to 1. So yeah, it is 0 to 1, right? Because that is the fraction. Okay. So I think down here then would be like 0.66. So let's go ahead and do that. So we'll do Y equals 0.667. And then let's try like 1.1. Okay. So it's down there. I think it needs to go further out. Let's try like a vjust equals 1. Okay. Let's shrink the size. And we'll do size equals 7, size unit equals pt. So that's smaller. So it needs to come further out, and I don't totally understand. I always forget my vjust if it's 0 or 1. Yeah, I don't totally understand why it's not putting it further out. Because x is 1. If I do like 1.5, and let's put this back to say like 0.5. So that pointed out a little bit further. I noticed the circles got a little bit smaller. So let's go a little bit further out. So that is making the circles smaller. Let's do 1.5, and let's maybe make this like 0.75. I'm getting weird results with these units, which is a little bit distressing. So let's see. And we're kind of getting short on time because I want to move on to doing a stack bar plot. So 1.5, 0.75, let's make that 0.7. What if we do like vjust or hjust equals 1? Oh, let's make it hjust equals 0. All right, that's a little bit better. And let's bring it down. I'm noticing that there is a grid line around that. And I wonder if I don't have, I think I have expansion on, but it says expand false. All right, what did I want to do? I wanted to drop that down a little bit. So that's going to be the Y position, right? No, it's going to be like 0.6. So that brings it down. Okay. Let's bring it up a little bit, so like 6.5, and put this out to say 1.6. All right. So it's making those circles smaller, which is annoying. And I'm noticing that there's something going on with the background of those circles. And so let's see if we do like panel.grid equals element line color equals black. Oh, it's unhappy because I put a plus rather than a comma. Okay, so it is adding an expansion, clearly, that I do not want to have there. So, does chord radial have expand? Let's look. And so expand is true. Does it have a comment about this? If false, the limits are taken directly from the scale. And so maybe we want to set those limits. And I also think maybe we want the clip to be off. So let's go ahead and then do rlim equals C0 to 1 and clip equals off. All right. Bah, that didn't work. Did I set? Oh, that's rlim. Let's see. Let's remove that. That's weird. I guess if I do panel grid, if I do element blank, so that gets rid of those, and those numbers are more or less in the right place. It is distressing to me that I've got those, that it's expanding out, right? Maybe if I do, what? Scale, no, rats. Let's see, that is in chord radial. And let's come back here. Limits for the theta and r axes. I thought I did this, right? So I did like, let's do theta lim equals c 0 to 1. Let's try that. Doesn't change anything. All right, and then r lim 0 to 1. And it's putting a donut in the middle, which I don't appreciate. What if we do like -1 to 1? No? It's annoying. I'm gonna leave it there, and maybe I'll go ahead and turn off those grid lines again. And this is a bit hacky, but I don't want to spend too much time messing on something that I think is not great. Let's maybe, again, shrink the panel spacing. Let's go back up to, say, 20. That brings that closer together. Two little things I notice is that this 0.7 doesn't have the trailing zeros. I want that, so we'll come back up to where I do this pretty P. I can do format around the round. And I can do n small equals 3. And so this will make sure that I've got 3 values to the right of the decimal place, even if they're 0, like here. The other thing I've got here is that 0. And so that 0 came in back up here when we did the pivot wider, pivot longer. And so here, before I make my pie chart, what I will do is to do a filter n not equal to 0 to remove that observation. It's not going to change what the data look like, but there we go. And I'm getting an NA value here. So that NA value is coming from back up here where I did this response, right? So I'm going to change that to maybe be sum. All right, I'm going to leave that there. Hopefully you don't mind. I think that looks pretty good. I think that looks pretty close. The little things that we might change, like the legend place. Well, let's do that real quick. The legend, I don't like how by default the points, the symbols fall midway in between. So what we could do within legend text then would be like margin equals margin. Let's do L, so it's to the left between the symbol and the text. Let's do like 1, and R, let's do 3. So that's gonna be to the right of the text, but before the symbol. We get something like that. And so maybe I will up that to like 2 and 5. Yeah, I think that looks cool. One final little detail is that in theirs, they have white lines separating those wedges. Again, I'm probably spending way too much time making this very ornamental, but I can do color equals white, and that color then is the line color, and that's too thick. So let's do line width equals 0.2, and so that then thins those lines down a bit, but you have the border on each of those wedges, right? Cool. All right. Now, so The problem with this representation of the data is that it is, it's hard to compare across time points the same treatment group, right? And that is the problem with pie charts, is that we're not very good at measuring fractions with our eyes when it comes to a circle. But like if I had to compare this to this to this to this, it gets hard, right? Because I'm like comparing here, then there, then back here, and back there. And especially that I'm trying to actually compare this distribution to this distribution, my eyes are like doing a lot of going back and forth. And so what I'd like to try in place of this pie chart is to make a bar plot. And so I'm going to put in some sections in here. So this is going to be the pie chart code. And so what you'll notice now is down here in RStudio, they put that section in. And we'll come down here and we'll then do stacked bar chart code. And I'm probably going to just start by copying and pasting this code down. And I will change this to be stacked barplot.png. And I'll keep it the same size. And so what happens if we remove this chord radial? So let's think about the design, right? Okay, let's not just like start randomly changing things or keeping things. So I'm thinking that I would, because I've got, if I want to just give them something that they can put in place of those pie charts, I want it to have the same dimensions. And so it's going to be wide and kind of short. And so one thought would be to have my stacked bar plots go vertically, or I could have them go horizontally, right? Let's start with having them go, let's go vertically, because people are used to thinking vertically. So I'll binned all my code down here and we'll grab it later if we need it. We'll go ahead and still remove that category that had a 0. On the x-axis, I'm going to want to put the treatment. And then on the y-axis, the fraction. The fill is going to be the response, and the label is going to be the n, right? And so then I might think about doing like geom call, right? So let's see what this looks like. And that's the pie chart. Let's, there we go. So this is the stacked bar chart version of the pie chart. And so again, we have the treatment, but we're not splitting things apart by time. So maybe on X, what we want really is visit, but then we don't have, the treatment. And I'm noticing that like we've got these like 2 red rectangles, 2 green, 2 blues, and that's for basically the 2 treatments, right? And so if I can't do something like position equals position dodge. Can I? No. Like that's doing weird things, right? Like that's not exactly what we want. Okay, so I think what I'm going to do is on the x-axis, I'm going to put treatment. And then I will go ahead and remove this position dodge. And then I'm going to do facet wrap tilde visit, right? So I'll have separate facets for each visit. So we get that, right? And so we have these stacked bars, but I want 1 row, okay? And so let's do n row equals 1. So we get something like that, right? And so hang with me for a minute, but like the reason I like this, or the stacked bar plot, and this is like monumental that I am complimenting a stacked bar plot, is again, if the test is comparing this distribution to this distribution, then I'd kind of like to see the distributions, right? The one thing I don't like about it is that my treatment names are long and they run into each other. Now, I could turn them, but that's going to then eat into the real estate that I have to show the plot. And so what I'm going to do instead is let's flip the axes, right? So let's make treatment on the y and the fraction on the x. And so we get that, right? And so I'm thinking here. The thing I liked about the other orientation is that it was easier to compare across times. But what happens if we so this highlights, comparing within each of the visits. But the other orientation was nice because I could compare within each of the visits, but I can also compare across the visits, right? So what happens if instead we do n call equals 1? And then we've got a lot of extra stuff in here, right? Then we have the benefit that we had before, that I can compare within a visit, but then I can also very easily compare across visits, okay? So I like that. I would like to have the time maybe on the left side and the drug on the right side. And I certainly want my legend on the bottom, okay? So hopefully you can see where I'm going here, right? So let's go ahead and let's put the legend on the bottom. And I think I had that. Oh, maybe what I'll do is I'll grab a lot of this stuff, all right? So I'm going to grab this labs on down and put it up here. And let's think about what we want. So we've got the labs. That's going to turn off all those labels. And then we're going to get our fills in. I'm going to go ahead and turn some of these off for right now. I will leave on my legend stuff. And let's go ahead and turn off the axis stuff, okay? And so there we go. We have our color scheme. We have our legend at the bottom. Cool. Let's go ahead and let's go ahead and put our labels, our drugs on the right side. And we'll come back up here and we'll do scale y discrete. And the position we'll say is right. And so that should put those labels on the right side like we have here, okay? Cool. Now let's put these labels for the facets on the left side. And so to do that, back up here in facet wrap, we'll do, what is the argument? I should try to think about this. I think it is strip, placement. Strip placement equals left. Nope. Let's see. If I come back up in here and go to the opening parenthesis and hit that, I don't get any help. All right, let's go to the help. Facet wrap. And strip position. All right. Should have known that. That was close. And so now we have the label on the left. But again, I want it to be turned 90 degrees. And so that would be done with, let's see. So panel background, we're going to get rid of the background. And then, oh no, hold on. Let's hold on to that. And all the strip stuff before was done down here in the facet wrap 2, right? I'll go ahead and get rid of this stuff just so it's not taking up space. All right, so what we'll do is strip.text. And I've learned when I do this that if I put something on the top, on the left, or things like that, then I need to be explicit with which strip I mean. So we'll do strip text y left, element text angle equals 0. And then let's do strip.background equals element blank. And I need a comma here. And so that then gets that. Looking good. Let's go ahead and remove the expansion all the way around. I'm going to use the panel spacing to change the spacing between the rectangles. All right, so do I have that somewhere in here? Oh, that's going to be up here in, let's see. Let's do in here, scale y discrete. We'll do expand equals c 0, 0, and that should remove the expansion on the y-axis, right? So now my bars go all the way out. And so now I want to add a scale x continuous, and we'll do expand equals c 0. And so then that fills that out left to right. Looking good? What do you think so far? Let me know if you're still watching. Let's go ahead and remove the background and the grid. So that would be back up here, this panel background and panel grid. And I can get rid of this. And so now I see that I don't have that gray background anymore. I think that looks pretty nice. I want to get rid, I want to get rid of these tick marks on the right side. And so we can do axis dot ticks dot y dot right element blank. I think I forgot a comma here. So that gets rid of that. Okay. One thing I kind of don't like about this is that we've got these names just repeating over and over again, which, whatever, that's not the end of the world. Maybe we could make that text a little bit smaller. So that's axis text dot y dot right. We'll do element text size equals 8. Maybe we can go down to 7. In some ways, like the actual drug doesn't matter because what we're saying is statistically they're not different from each other, right? And then on the x-axis, we have the fractions, and I would rather that be percentages. So what we can do is in scale x continuous, we can set the breaks and the labels. So we'll do breaks equals seek 0 to 1 by 0.25. And then my labels, I'm going to seek 0 to 100 by 25. And that gets me those. Now, this text is actually gray. I think this also is gray. So let's go ahead and make our axis text on the right. I'll do color equals black. And then axis text x, element text color equals black. And then my axis ticks, I'm going to make them a little bit thinner. So I'll do axis element line width equals 0.2. So that cleans that up a bit. Maybe those numbers could be a bit smaller. So let's do like size equals 8. Yeah. Maybe what we need is a little bit more space above the legend. So legend box spacing, let's maybe take that up to 2. That's not bad. All right. So we don't have our p-values in here. And so what I think I'd like to do is like 5 days, and then below that, maybe in parentheses, put the p-value. And so let's see. I don't think I don't need any of this other stuff. Okay. So let's then think about that. So again, we have our D and our CA test. So the other thing that I notice in my visit is that my visit is out of order, right? Like if you look at this, it goes 5, 30, 15, 6. I want it to go in chronological. We did it in a weird order to get the pie charts to go in the order we wanted or to match what they had. So if I look at CA test and D, I've got this visit column and this visit column. And so what I'd like to do is join these two data frames together so that I'll have a p-value and the visit, right? And so maybe what I can do is like CA test select visit p-value, right? So that gets me those two columns. And then I can do an inner join with D by visit. Right, and so that will then get us, oh, it's missing. Maybe I need a period there. There we go. Oh, and I think I ran too much. All right, let's run that. And so now what we've got is our visit, our p-value, and our treatment, right? And so what I'd like to do then is to then mutate and make visit p, and we'll do paste visit. Then I have p-value. I thought I had a pretty p. Maybe that's what I want instead, is pretty p. All right. Okay, and so we'll paste visit, and then we'll do pretty p. Let's go ahead and do paste 0, because I'm gonna add in some text here. So we'll do \n parenthesis, open parenthesis, pretty p, and then a closing parenthesis. And so now what we see is we have this visit p over here, although it's making an extra column, and I think, oh, this needs to be inside that parenthesis with a comma. There we go. And so now we've got that. And I'm also going to want to make visit p a factor, and we'll do, can I do visit p, maybe do fct reorder, visit p, and we're going to reorder it by visit. And it's upset. And maybe we'll do levels of visit. Nope, that doesn't work. Let's just try it without messing with a factor and see what we get. All right. And so then our x, we're going to want visit p down here, right? And so instead of, well, that's going to be the y, right? Instead of treatment, we'll want visit. Nope. The facet wrap is going to be by visit p. Okay. All right. There we go. And it's not in the right order. Bah. So now we have our label here. That's okay. We need to get that in the right order though, right? So let's think, how do we do that? So we've got this visit p, which is a character, and I want that in the same order as visit. So maybe what I could do would be like arrange visit. So make sure that things are in the order by the visit. And then in here, I can do visit p equals factor, visit p, and that the levels are the unique visit values, or visit p values, right? Does that work? Doesn't yell at me. It makes it a factor. I think it's going to work. Voila. 5:30, 15, 6. But it's in the wrong order. It's back into that order, right? So let's come back up here. And after, let's see. We need to change the order of visit. So visit equals factor, visit, and then I'm going to copy some code from back up here where we did the D. So this, right? And where did I plop it here? And again, we're going to want to switch the 15 and the 30 and put a comma there. And didn't work. Oh, because I'm arranging it up there. All right, we need to pull this out and do a mutate here on that visit. And then we've got our arrange. Now it should work. Yeah. 5, 15, 36. Wonderful. And there we go. All right. Let me know what you think if you're still tuning in. Cool. So that is our stacked bar chart side by side. This, of course, is our pie chart. I would like to try one final thing, if you'll indulge me, and that is to do a dot plot. And so one thing I feel about these data is that, So the alternative to a pie chart is a dot plot, where you, on the x-axis, put the variable that you're, or you might put time, or sorry, you might put your fraction, and on the y-axis you might put your variable, and then you represent the fraction with a dot, right, or with a symbol. So again, if we take D, and I'm going to go ahead and save this, and let's save this as dot plot. Okay, so we'll then do ggplot AES x equals, and so across the x-axis, let's again put our fraction, our y. Let's do our visit, and maybe we'll do visit, and then our fill or color. We could then make our response. I'm going to use a plotting symbol 21, and so we'll do geom point, and we'll do shape equals 21. And so if I open up dot plot here, well, okay, that's not exactly right. Right. So we have kind of this problem that we saw earlier with the stacked bar plot. Sorry, I'm looking at this and I'm thinking at the same time, which is always very dangerous. So we don't know which drug is which, right? And so we could do the same type of thing that we did before with those stacked bar plots, right? So why don't I go ahead, actually, and I'm going to copy this code down and make the conversion to the stacked bar plot. So we're going to just kind of think about like what we're going to keep and what we're going to change. So again, this is going to get us our time, right? We're going to remove the n. Actually, I want to keep the n equals 0 here because I want to have a point at 0, right? So let's leave that in. We have treatment, fraction, fill being the response. I'm not going to put the label because I think that's going to be just too much. And then let's do geom point. And I'll do shape equals 21. And then we're going to, again, do the faceting, the labels, all this stuff. Let's see what this looks like. It might be actually really close. Okay, well, it's not exactly really close. That's interesting. Very interesting. I'm just kind of taking this in for a minute. You can see the makings of something here, right? And so what you maybe see is at the top, we have that nitrofurantoin and our anakinra. And that's because like on the y-axis, we have those values, right? And we removed the expand on the y-axis. So let's come back up to that scale y discrete. And I'm gonna, for now, remove that expand. And so that we see then pulls that in a bit better, I think. And maybe on the x-axis, we want to apply an expand also because we've got this point here and this point here that are getting clipped off, right? We could turn off the clipping, but this is still going to run into the label. So let's go ahead and on the scale x continuous, I'm going to do expansion as a helper function. And we could do molt. Let's do add. And let's do C 0.02, 0.02. So it should add 2 100ths to either side. Yeah, I think that's good. Something that I think is happening is like some of these symbols are actually on top of each other, right? So like I've got 2 symbols here at 6 months and 2 here for 30 days. And so they're probably on top of each other. So let's come back up to geom point and we'll do position equals position dodge. Oh, and it wants me to give a width for my dodging. So let's do width equals like 0.05. Okay, that didn't do much. Let's do 0.2. Yeah, so we can see down here that there's points on top of each other. Let's go ahead and make it 0.5. Okay, so I think that's better. One thing that we can do then is put a grid line through to indicate kind of what data corresponds to nitrofurantoin or the anakinra. And so we'll do panel. So I did panel grid. Let's do dot major dot x is blank. And we can also do the minors as being blank. Right, so that gets us that. I mean, we can't see anything, but let's then do panel.grid.major.y equals element line. And we'll do line width equals, say, 0.2, color equals dark gray. And so then that gets us our line for those 2 values, for those 2 drugs, right? And I don't know. So this would be the dot plot replacement for what I have down here, right? And so this is nice because I can compare like the individual values, right? So if I only wanted to look at all symptoms or all or some symptoms are gone, then I'm looking at these green dots and looking how they track, right? And if I want to see if someone has the same symptoms or worse, I can then track this red line all the way down, right? And something I'm noticing is that my grid lines go to the left of the 0. So maybe, yeah. So like while I'm thinking about this, like the problem with this though then is that the p-value is for the complete distribution. It's not for like a single value. And so this is where I come back and think, I think the stack bar plot is the way to go, as hard as it is for me to say such a thing, right? And so maybe, I don't know, I think I would actually roll with the stack bar plot. The other, I see I don't have it here, but the challenge with the dot plot is that I don't have an indication of the n. I can add that to the stack bar plot. And so I'm going to do two things really quick before I finish here. I'm going to turn off this expand on the left side so that my grid line doesn't go off the left side. And then I'm going to add the n back to the stack bar plot. So let's come back up to here. And so we'll add 0 to the left. But my point's getting clipped there. And so what I can do is, let's see, I can do chord Cartesian clip equals off. And that then stops that point from getting clipped, right? And then, okay, I'm just looking at this, taking it all in. All right, so now let's turn back to our stack bar plot and add the n in. I forgot to do that. So let's come back up here, and that would be with my geoms. Let's then do geom text, and we'll do, well, we already have label being n, right? But remember, we want that position equals position stack, and we want to give that argument vjust equals 0.5 so that it's centered. And so we got those there, but those are pretty beefy labels. So let's go ahead and shrink it down a little bit. So we'll do size equals 7, size unit equals PT. There we go. All right. So let's see. So we have our three options here. We have our dot plot in the lower right corner. We have our stacked bar plot here. And then we have our pie charts here, right? And so the question is, which is better, right? And I am usually the guy that's saying, do dot plot. But again, for the reasons I already mentioned, that the p-value, the investigators were interested in comparing the overall distribution, then I think this is the way to go, right? Like, I think you now have to do too much work to think about the distribution, the placement of these 3 points relative to each other as we go through. Whereas here, that's like the design of the plot, right? Is that we've got that set up in the way we want it, right? And yeah. And whereas then like the pie charts, of course, we're just having to do way too much work all the way around. Okay, one final thing. I know I said I wasn't going to do this, but it appears that my categories of my responses are flipped. Instead of having like something be good, like I'd rather have this green be on the left, because like they had a secondary analysis where they're trying to actually compare the green to each other, right? So it's like a secondary analysis they had, or secondary type of question they had. And so it'd be nice to have the green on the left. And so I wonder if I still had in here something about my levels. So my responses were defined way back up here. And Okay, let's come back down here and look. Oh, I've got my visit. No, I want the response to see if the response is a factor. It's going from better, some, worse. And I think this is a thing in position stack. And so if we do position stack, there's a reverse equals false. And so I think that's what we want to do is reverse the stacking order. Okay, so back up here, we'll do position equals position stack reverse equals true. And I think here we also need to say reverse equals true. And so there we go. Now we do have the green on the left. This also matches the legend pretty nicely, right? And so, yeah. So like I said, these are 3 options. I'm running a little bit on time here. So I would love it if down below in the comments, you were to leave me with your thoughts on how I did here and what of the 3 options you preferred. Again, my indecision, at least between the stack bar and the dot plot, comes down to what was the question? What are we trying, or what were the authors trying to get at? And I think if they're looking at the overall distribution, and that's what these p-values indicate, then we should show the distribution. If they're interested more in the individual points, then something like the dot plot, I think, would be more effective. All right. Well, that's all I have for today. Thank you so much for watching. I know this was a bit of a slog and a bit fast, and I hope you learned a lot about this GGH4X package that is kind of like a collection of hacks, as they say, to the ggplot2 library. All right. Well, as always, if you see anything out there in the literature that you come across that you would love to see how I react to it or how I would go about creating it or making it better, by all means, leave a comment down below on this video. I do read all the comments and try to respond to them. Feel free to send me an email. But yeah, please tell your friends what we're doing here on Code Club, and I will see you next time for another critique, refactoring, and